Hello dear friends, welcome to my channel. Today's discussions is Galois theorem, Galois groups. So this problem is coming from CSIR NET examination. So let's start to solve this question. Pick the correct statement Q root 2 Qi are isomorphic as Q vector space, Q root 2 Qi are isomorphic as fields, and Galois Q root 2 divided by Q isomorphic to Galois Qi Q, and Q root 2 and QR are both Galois extension of Q. So friends, solution: Q root 2 such that Q equals to 2 and Qi such that Q equals to 2. So Q root 2 and Qi are both isomorphic as Q vector space. So option A is correct. This option is correct, true. Option A is true. Next friends, next is option B. Q root 2 and Qi are isomorphic fields. Q root 2 and Qi isomorphic fields as phi such that Q root 2 tends to Qi be an isomorphism. So phi A plus B root 2 equals to A plus B phi root 2. Using the fact QQ acts as identity, so Q root 2 whole square is equal to Q root 2 into phi root 2, and as a homomorphism, so it can be written root 2 into root 2, so it is phi 2 equals to 2. So phi root 2 equals to plus minus root over 2. So which is wrong? That plus minus root 2 does not belongs to Qi. So whatever we get, option B is false. So option B is false because Q root 2 and Qi isomorphic as fields. This is not possible. Now next we see number C, question number C. Option C. Option C, the Q root 2 such that Q is equal to degree of irreducible polynomial satisfied by root 2 over q is equal to 2. So friends, q I such that q equals to 2. Using Galois theory, using Galois theory, order of Gal q root 2 by q and order of Gal qi divided by q equals to 2. It is 2. So both are isomorphic to Z2. Isomorphic to Z2. So option C is correct. That means Gal q root 2 divided by q isomorphic to Gal q root 2 divided by q. So option C is correct. Option C is true. And after that, friends, we see both are q root 2 by q. Option D. For option D, q root 2 by q and qi divided by q, both are algebraic extension and also any automorphism sigma such that q root 2 tends to q root 2 and tau such that qi tends to qi fixes the elements of q and fixed field is q. So both are Galois extension, q root 2 divided by q and q root 2 divided by qi divided by q. Both are Galois extension. So option D is true. Thanks for watching, friends. I hope I can clear this concept.